So today, yeah. So this is Ambika from Provoke Trainings. Today I'll be covering few concepts in SQL. This is again the theoretical part. From Monday onwards, we'll be directly working on the queries. So we have to understand the concepts before getting into writing the queries. So I'll be completing this rest of the theory part today. So yesterday we were discussing about the SQL constraints. So in the SQL constraints, what is exactly it is? They are the rules applied to the table columns to ensure the accuracy, integrity, and reliability of the data in the database. You are going to create some rules for each column. Maybe for one or two columns, maybe for all the columns. It is up to a requirement. But these rules are getting applied to the table columns to ensure the accuracy of the data, so that there is no duplication, there is no null values, and data is reliable. They help make sure that invalid data is not inserted. You are not having the bad data in the database. Relationship between the tables stay consistent. So for example, you are going to create one table with the primary key. You are going to create another table with the same primary key as a foreign key in the table. So you are going to maintain this relationship using this constraints. So this is what SQL constraints. This is very important when creating the table. While creating the table itself, you have to provide these constraints, rules and regulations to the table so that your operation will be predefined and whatever the results you are going to get for the query will be accurate. So that it is connecting two tables or 2 to 3 tables, it will be perfect to get the perfect results. So first, not null constraint. Not null means ensure that a column cannot have the null values. Your column should not have empty values. Empty values means in the rows. Whatever the rows you are going to insert into the table, it should not have null values. Create table, student. This is the syntax. Student ID is the column with integer data type, not null constraint. So I'm making sure the student ID will not be having the null values. Name varchar of 50. Varchar is a data type which is having the 50 length of the characters 50. Again, it is also not null. So you have to make sure you are not inserting the empty records in the student ID and student name column. And again, age is the integer. Here we are not providing any not null constraint. Here, student ID and name must have values when inserting the record. So you should provide them values. With the null values, you cannot insert the record. This is the first constraint, that is not null constraint. Any doubts? Next is unique constraint. Unique constraint ensures that all the values in the columns are different, no duplicates. In the primary key also, we are taking care of the same thing. But this unique constraint, it's making sure that again rechecking that there are no duplication of the values in the rows. It is going to take care that all the values in the column are different. 101 should not be repeated for multiple rows. If I am going to create the 10 records in the table, it should have 101, 102, 103, 104, 105, 106 to 110. So 101 should not be repeated. That will be taken care by the unique and the primary key constraint. In case primary key misses that operation, the unique key will be taking care of that operation. So primary key serves two purposes. So one, it is going to connect to the primary key is going to act as a foreign key in another table, as well as it is going to maintain the uniqueness of the data. So this unique key constraint is also going to take care of the uniqueness of the data. So create table employees. In this, you are going to have the 3 columns. Employee ID. For this, I'm going to give as a unique constraint. Employee name is a varchar. It is a string data type which takes the character of 50 as well as email 100. So email, employee ID and email are unique constraint. so that they should not have the duplication of the records and the same record should not be repeated. So that one I'm taking care in these two columns, employee ID and email in this employee table. Both employee ID and employee email must be unique across all the records. This is called unique constraint. While creating the query, while working practically, you will understand like what the primary key is going to do and what the unique key is going to do, unique constraint. So these are the rules we are going to write into the columns to check, to make sure that you are following these things in the whatever the records you are going to insert into the table. Next, primary key constraint. So a unique identifier for each record in the table. It combines not null plus unique. So primary key is a combination of not null plus unique. It is primary key is going to take care that you don't have the null records as well as the no duplication. In case primary key violates that, you can provide the column with the unique constraint so that the duplication of the records will not be allowed, which will be taken care by this primary key constraint and unique constraint. But primary key is going to do these two operations. It is going to take care of the null records as well as the unique values. And you can have only one primary key per table, but you can have more unique keys. For example, in this previous slide, I have created employee ID also unique, as well email ID also unique, but I can have only one primary key per table. So create table. Table name is departments. Column name, department ID, integer primary key, department name. So in this, I'm creating only one primary key. Department ID uniquely identifies each department. Any doubts in primary key unique constraint not null? Foreign key. It creates a link, relationship between two tables. It ensures that the value in one table exists in another. This one I explained yesterday, but still let us cover all these constraints one more time to make clear that these all comes in the data definition language. While creating the table only, you have to provide all these rules and regulations. If you want, you can alter it later using the alter command. So we will be working on all the queries one by one with more examples so that you will get strong understanding of the SQL. Whomever coming from IT knowledge and non-IT knowledge, everyone should become comfortable in writing the SQL queries so that in the Snowflake, it will be easy for you to understand when we are going to do the multiple operations. Creates a link, relationship between two tables. It ensures that value in one table exists in another. Create table employees. This is the command. In this, I'm going to have 4 columns: employee ID, employee name, department ID, foreign key. That's 3 columns. The foreign key is employee department ID. So the first column is going to be the employee ID with the data type integer primary key. Employee name takes a varchar of 50 characters length. Department ID again integer. So this is the foreign key of the department ID that is referencing the department table. So for this employee table, I should be having the department table also with me so that the primary key of the department ID will be acting as a foreign key in this employee table. It makes sure the department ID in employees must exist in the department table. If you are going to create a foreign key, definitely you should have 2 tables, the source table for the foreign key and the current table. These are the requirements for the foreign key constraint. Next is check constraint. Ensures that column values meet a specific condition. For example, in general programming, you write the if condition, right? And you will be checking for multiple conditions: if, elif, else. So in that, what you are doing, you are going to check some condition. But in the Python programming, you have the syntax for that. But in this SQL, we have a syntax of checking multiple condition is case we have to use switch case we have to use for the checking the condition. Okay, that is while writing the SQL query. What if I am supposed to check the condition while creating the table itself? I don't want to check this condition for this column while writing a query to access the table. You are going to write a SQL query to retrieve the data from this products table. That time in the var class, you will be mentioning the condition. Instead of that, why can't I give the condition while writing the table itself, while creating the table itself? That is called check constraint. Here I'm going to create a table products with a 3-column name, product ID, product name, and price. It takes an integer data type, varchar and decimal. So in this price, I'm going to check all the prices should be greater than 0. It should not have the negative values. So this one I'm checking while creating the table itself. That is possible using this check constraint. So this prevents entering any product with a negative or 0 price. Any doubts in this not null, unique, primary key, foreign key and check constraint?
No, unique key constraint. Any null values it allows?
Which one?
Unique key constraint.
Unique key constraint.
Not null it allows any not null.
Unique key constraint, mostly it will take care of the duplication of the data. But primary key will take care of the not null and unique constraint. Unique key is going to take care of only the not null duplication of the data. Because you will be having the records without nulls only. I mean, you cannot have the null records when you are going to check for the unique constraint. But primary key is going to check for both not null and unique. Clear?
Yes.
So in this check constraint, I am repeating the difference. While writing the SQL query to retrieve the data from the table, I am going to check some condition in the query. Rather than that, while creating the table in the data definition language itself, I'm going to check the condition so that this price column should not have the negative values. Using this check constraint, it is possible to provide that condition in creating the table. Next is default constraint. It assigns a default value when no value is provided. Here, I'm not going to provide any value for the row. That time, I have to provide the default value in the column itself while creating the table itself, so that for the empty rows, it has to provide this value. So I'm going to provide the default value for the particular column. So create table. Table name is orders. It has got 3 columns: order ID, order date, and status. Order ID takes integer data type, it is a primary key. Order date is a date column, date data type. Default it is current underscore date. So when I am not going to insert any date for this order date, default it is going to assume this current date as a value for that particular row. Wherever I don't provide the date. And status is the one which is default pending. I want all the status to be pending, default. If I'm going to provide some other value, then it will take that value. If I'm not providing any value, that time it will take default value of the status column is pending. So this is called default constraint. You are going to replace the empty value of the rows with the default value. That is called default constraints. If no status is entered, it automatically becomes pending. If no date is entered, it automatically becomes current date. Any doubt in this constraint? Next is auto increment. It automatically increases the numerical values often used with the primary key. Create table customers. In this customer ID integer, I am giving auto increment. So from 1, 2, 3 like that, it will auto increment for each customer ID. and that one I'm considering as a primary key. So the ID of the customer will be incremented automatically by SQL itself. So it increases the numerical value often used with the primary keys. For example, I'm giving the first value as a 101 for this customer ID. It will auto increment as a 102, 103, 104 like that. So this is what auto increment operation in SQL. So this is also we will be widely using while creating the tables. It increases the numerical values. Any doubts in these constraints?
Well, it seems like identity key also, right?
Which one?
This one auto increment. Identity key also same like that only. 1, 1, 1.
I'm not getting your question.
It seems like identity is same like identity also 101.
102, yes, yeah. Because it won't generate the duplication. It will, as you said, it will create the identity. It will maintain the uniqueness while creating the auto increment values. Your question is correct.
Entire primary key is only applicable, man.
Which one? Here, here I'm creating only 2 columns. So for one column, I'm giving primary key. If you want, you can create another column, but primary key will be created only once in the table. You cannot have multiple primary keys. You can create another column with a unique key, unique constraint.
So I'm asking about only primary key and foreign key combination. It will applicable part of implement.
You can, it is applicable, but for the foreign key, you should have another table connecting this. Whichever the column you are going to maintain as a foreign key, you should have the dependent relational table when creating the foreign key. Your question is answered.
So it is applicable to one table to other table links like that.
Yeah. Foreign key is different. That is why it comes under the relational table. If you want to have a foreign key here, you should have the parent table for this key, for this particular table. Then only the foreign key you can create. If you are going to have only primary key, you don't need to have the relational table. But foreign key means you should have the relational table. You got the answer?
Yes, madam. I got it.
Okay. So now this is final summary. So not null ensure that column cannot have the null values. Column means whatever the rows you are going to insert for that column. Unique. It ensures all the values in the column are unique. Primary key uniquely identifies each record. Rather than theoretical, when I create and show, then from Monday, you will understand it better. And when you write by yourself, you will be far better. Foreign key, it ensures the referential integrity between tables. That's what I said. You should have the referential integrity. Parent table should be there. Check constraint, ensure the values meet a specific condition. And the default is, it says the default value when none is provided. So this is what about the constraints. Once again. Sharing my screen. So now we are going to learn about SQL operators. So for example, this is the student table. I have name column, age, class, and marks. So I'm going to have the set of names, age, class, marks. These are the columns and rows I have inserted in this table. Now, how should I select 2 columns from this table? If I give select star from student, it is going to pick all the columns. Student ID, name, age, class, and marks. It is going to pick all the 5 IDs from this, 5 columns from this table when I give select star from student. But when I'm going to give select name, comma, marks from student, it is going to select only 2 columns. So this is the select statement where you will be selecting all the columns using the star. Select star from student will pick all the columns from the table. If you give name, comma, marks, you will be selecting only 2 columns from the table. This is called selecting specific columns. Now, filtering rows using where condition. Where is the class? It is helpful in the select statement when you want to check for some condition. Select star from student where class is equal to 10A. So in this, we have 10A, three classes are there. But in the input record, you have 10A, 3, 9B and 10B. You have 5 records. In the 3 records are 10A. So in this var class, I'm going to filter only the class which is having the 10A. So it is going to select the records from the student where class is 10A. So where is the class? Class means not CLASS, CLAUSE. It is a clause in the SQL query language which is going to filter for some particular condition while selecting the rows from the table. I don't want to see all the rows. I want to see only the rows which belongs to the 10A. For that only, I'm going to provide this var class. This is for filtering the rows. Next is show students who scored more than 70. I'm going to select name, marks from student table where marks is greater than 70. So here from this student table, in this previous query, I'm selecting all the rows. Whereas in this query, I'm selecting only the few columns from the student table where marks is greater than 70. So whomever got marks greater than 70 only, it will be displayed. So if you see in the original one, you have how many records greater than 70? 3 records greater than 70. These 2 are less than 70. So that's why it is filtering only the marks which is greater than 70. So here you are applying 2 things. You are selecting only few columns and for this particular condition. Using logical operator. I hope you should be familiar with the logical operator. So logical operator is AND operator, OR operator, NOT operator. AND operator, how it works? To say AND as a true result, I should have both the conditions true. Both the conditions should be true, then only the AND will give the true result. OR condition, either 1 can be 0 or 1 can be, either 1 can be true. That is called OR operator. NOT is inverse of the given input. So these are the ways how the AND operator, OR operator and NOT is going to work. Now, in the students in the class 10A and the marks greater than 70, both should be true. I want class should be the 10A and marks is greater than 70. Both the conditions should be true. Then only I will get the rows. So AND operator is going to check for both the conditions should be true. But OR operator will check only for any one of the condition is true. Here I have given the example for AND operator. So it will check for both the conditions should be true. So the record should be 10A and marks should be greater than 70. If you see here, so 10, let us go. 10A is 2 records and marks is also greater than 70. That is why we are getting this result. Understood this logical operator? Next is comparison operator. Comparison means what? Relational operator. These are the basic operators will be used in all the programming languages they will be used in the conditional statements. Conditional statements means if condition, while loop, for loop. There you will be using this relational or comparison operator. Equal to, marks is equal to 90. Greater than, you are checking age greater than 15. Less than, marks less than 60. Greater than equal to, marks greater than equal to 80. Less than equal to, age is less than equal to 16. Not equal to, or the not equal to can be mentioned in these two ways. That is class not equal to 10B. So these are the conditions you can mention in this AND operator or operator. You are going to check for two conditions or you are going to check for only one condition, but there this comparison operator can be used. So marks, no need to have the class here, just checking where class is greater than equal to 70, less than 70, less than equal to 70. So that is the way you are going to check, and you are going to check class not equal to 10A and marks greater than 70. So all this relational or comparison operator will be used in this var class. Any doubts? So all these comparison or relational operator will be used in the var class to check for some condition. Next is filtering using the like operator. Like is used for the pattern matching with the wildcards. Wildcard means special characters. Percentage, underscore. So we are now, in the previous slide, you saw the example of filtering using the var condition. In this var condition, you are mentioning only single condition with the double condition, and now we are going to use the like operator in the var condition. Percentage means it is going to, this like operator will be using this symbol while checking the condition. The percentage is any number of characters, underscore means only one character. These are the two special symbols it is going to use. The symbol pattern. These are the two things like operator is going to use for filtering the condition. So like operator, name starts with A. Select star from student where name like A percentage. So wherever the name start with the A. So percentage means it is going to check for any number of characters after A. If I give underscore, it is going to check for only one character. So names ending with A. Select star from student where name like percentage A. So the percentage A means the characters that ends with the A. A percentage means the character that starts with the A. So this is the like operator which will be provided in the var class for checking the condition with the strings. It is getting operated with the strings, not with the numerical values. For numerical values, you will be using the relational operator and operator or operator. Logical and comparison operator will be using with the numerical values. In the string values, we will be using the like operator. We will see more example while writing the queries using this. But basically, the filtering we are doing with the var class. Using the var class only, I'm going to do the filtering. In this filtering, there are multiple types, giving only one condition, checking more than one condition, using and or operator, and using the like operator in this var condition. Any doubts? So these are the ways how we are going to filter the condition. Now, between operator. Select two columns, name, marks from student where marks between 60 and 90. If you go and check the input data, you will, by seeing the data only manually, you can check like what are the columns coming between 60, what are the rows coming between 60 and 90. Correct? So I want to check the marks which is between 60 and 90 means I have to provide the between operator. In operator and is null operator and order by. In means we are going to learn three operators: in operator, is null and order by. In means it is going to check for some whether these two values are present in this set of rows. Please retrieve all the records where class in 10A and 10B. So it is going to retrieve the students from only classes 10A and 10B. Where given the condition, I can give like where class equal to 10A and class equal to 10B. So both should be true. Using the AND operator also, you can implement this query. And using the IN operator, it's better to implement this query so that whatever the records belongs to 10A and 10B, it is going to retrieve. Select star from student where marks is null. Whichever the records having the null records means missing marks. So it is going to find the records with the missing marks. Select star from student where mark is null. So this it is going to retrieve the records which is not having the marks. The empty records of this student table for the marks column will be retrieved. Select name comma marks from student. If you see in the first two queries, I'm selecting all the columns, all the rows. But here I'm going to select only the two columns. Here I'm selecting all the columns. Here I'm selecting only two columns. From student, order by marks descending. So it is going to retrieve the name and the marks of the student in the descending order. So if I'm having the marks here, let us say here, 85, 74, 60, this is a descending order. Bigger to smaller. In that order, it is going to retrieve the record. So the operator is in operator, is null and order by. The in operator is going to retrieve the records which includes both 10A and 10B. So this is applicable in the var class for filtering. Again, I'm going to use the is null operator. This is to check the null records from the particular table. And here, using the order by, I'm going to order the student marks in the descending order. So this is another type of the operator. Now, select is choose columns. You can choose the columns, whichever, I don't want to see all the columns. Then you have to choose the columns. The var class, it is going to filter the data where marks greater than 70. I'm going to use the and operator and or operator to combine the condition. So I'll be having class and age both. Both the condition should be true for the AND operator. Like means it is going to follow the pattern. And between means it is going to take the range between 90 and 60. In operator, it is going to take two values. It is going to check whether these two are in the given set of records. It is going to retrieve both 10A and 10B from the given set of records. Order by is going to sort the results. So this is what we learned completely about the filtering of the data using var class and different types of the operator. Relational operator, logical operator, like operator, between operator, in operator, is null operator and order by. Any doubts? And you'll be, from Monday, I'll be writing all the queries for each operations so that you will get the practical knowledge. How it is working exactly with the given set of data.
This is all called as basic operational command with SQL, madam.
Correct, yeah. These are the basic things you have to learn. If you are strong in that, the same only you'll be implementing the Snowflake, but you should have the basic SQL and advanced SQL knowledge so that it will be easy to handle the Snowflake queries. For example, if you are going to learn the Python language, there also we will be learning all in the basics. We will be covering all this. What are data types? What are the types of operators in Python? Supported. What are the numerical operators supported by Python? What are the string operator? The same way you will be learning with all the programming language for the basic level. Any doubts in this?
No, PLSQL also works in this SQL.
Yeah,
Snowflake.
PLSQL, for that, if you know the SQL basics, that is a procedural language. You will be writing procedures more in the PLSQL when compared to the basic SQL. You will be writing the stored procedures a lot. Your queries are answered?
Yes, yes.
Sure. So let me go to the next one. Just a minute. So now I'm going to cover the SQL functions. SQL functions are built-in operations that perform calculations, manipulate data, or return specific information from the database. We have in all the programming languages, we have the built-in functions. For example, if you take Python, Python has got some built-in functions, and we will be writing our user-defined functions as well. Like that, SQL also got functions. SQL functions are built-in operations that perform some calculation. It manipulates the data and returns specific information from the database. They make your queries simpler and faster. Types of SQL functions are single row functions. It works for only one row and returned one result per row. So it is going to work on only one row and return one result per row. They are checking all the characters in the given input is lower or upper character and find the length of the input. These all will operate only with the single row functions. Aggregate functions work on the multiple rows. For example, I want to count the number of rows in the table. I want to find the sum of all the records. Sum of the marks 1, sum of max mark, sum of science mark of the student. I want to get the average of all the five subjects. I want to get the maximum of student who got the maximum mark in science. I want to know the minimum max mark from the student table. For this, it is going to operate on multiple rows. So it is called as aggregate function. The single row function means it is going to operate on only one row. So these are the SQL functions defined into two types. Now, I have the student table. 1, 2, 3 is ID, name and marks. I have 3 columns here, 3 rows. Now, this is a single row function which is going to operate on the student table. Select upper of names from students. So it is going to convert all the names into uppercase. So it is going to work on single rows. It is going to convert all the names of the student into lower case. If you see the second result, everything is resulted in the lower case. In the third one, you are going to calculate the length of the name. So first is 4, second is 4, the third is Kiran is 5 characters, so it is 5. Select round of 78.56 as a rounded marks. So 78.56, if you round it, it is going to give the higher value 79 because 78.56 dot 5 is greater than 5. So it is going to give the next nearest value which is 79. I am going to concatenate the name and the marks using the hyphen. For that, concat of name comma within single quotes give hyphen comma marks from the students. So Asha hyphen 85, Ravi hyphen 90. So this is the example of the concatenating marks and the name. So these are the functions, built-in functions of SQL, which is going to operate on each row of the table. Any doubts? Next is aggregate function. This is going to operate on multiple rows. So it is not, for example, if I am going to check the count of start from students, the entire table it will check and it will tell me the count. If I am going to find the sum of the marks, it is going to take all the rows sum and going to give me the result in the numerical value. Whereas here, it is operating, taking each row and converting into uppercase, taking each row and converting into lowercase. But here it is taking all the columns, multiple rows at a time, and it is giving me the result. So these are all the numerical values what I got. Here I am getting the result only for the requirement. So here count of start from students 3 records. Sum of the marks 85 plus 90 plus 78. Average is 85 plus 90 plus 78 by 3. Maximum mark is 90, minimum mark is 78. So this is multiple row function, that is aggregation function. Basically, in all the programming languages, aggregation function supports these operation: count of the records, sum, average, maximum, minimum. For finding the statistics, we will be using the aggregate functions. And this is going to operate on all the rows at a time. And this is going to operate at a single row at a time. That is why it is called single row function. This is multiple row function. So when applying the aggregate functions for group, now how you should write the query. Select course, comma, average of marks from students group by course. So group by is a functionality. It is going to group by the course column for all the records. Generally, for a huge volume of the data, for example, in my Snowflake, I have millions of and billions of data. Means that time in the projects, generally they will try to avoid, if they have more number of columns, they will try to avoid the group by, because using the group by, there are some chances you may miss some records, because it is going to group by only the course. So if some other column has to be covered, that time the data will not be accurate. So group by is supportive for small number of data and medium number of data. For large number of data also they will use, but if they are very sure like what is the result they are going to get, that time only they will go by group by. So in the group by, what is the order we should give is, before the aggregate function, whatever the column you are giving, that one should come in the group by functionality. I'm repeating one more time. In this select statement, before this aggregation function, what is the column you are giving? That one should be mentioned in the group by functionality. If you are going to have the course, comma, student ID, you should mention course, comma, student ID in the group by. Whatever the columns you are going to mention before the aggregation, all the columns should be mentioned in the group by in the same order. You should not change the order. If you change the order of the columns, the result will not be appropriate. So quick summary, single row functions are upper, length and round. This is going to apply on each row, one value per row. Aggregate functions are sum, average and count, which is going to apply in the group of rows. It is going to access one value per group. So this is about the grouping. So far, whatever the things we have learned today, what are the constraints in Snowflake? Primary key, foreign key, check constraint, not null constraint, unique constraint, default constraint, and auto increment. So these are the constraints we learn in detail with all the examples. Similarly, next we learned about grouping SQL rows, types of the SQL functions. In this single row function means what? Aggregate function means what? The single row is going to operate on each row and aggregate function is going to on the multiple rows. And what is grouping? So how to write the group query? If you are going to use the group by functionality, how the query has to be written? If you are going to mention one column before the aggregation function, then that column should be covered in the group by. If I'm going to mention two columns before the aggregation function, two columns should be mentioned here, but in the same order. We should not change the order. This is what about the built-in SQL function. So SQL function. And also you have learned about SQL operators. So in this SQL operator, you have learned about is null operator, between operator, logical operator, comparison operator, and many operators you have learned today. Let me know if you have any doubts on this. So that from Monday, we will be start writing the queries from the data definition language. So we will be writing queries in the data definition language, data manipulation language. How to create a table with the primary key and foreign key, how to insert the records into it, and how to retrieve the records from the table. From the basics, I'm going to start writing the query before you on Monday. So let me know if you have any doubts in today's session.
Tomorrow, if you have the class or not, madam?
I'll just I'll update you. You can contact the institute. Mostly will be on Monday. They will update you. So I'll be sharing this PPTs so that you can go through that one by one. So that Monday when we start writing the queries, you will be understanding it better. When you are going to have some theoretical knowledge on that. Or if
The
you have this
recording,
recording,
what about recording classes, madam?
recording
Today
of
and
the class.
yesterday demo class.
Yeah. We can. I can check with the institute and I can share the recordings to you so that you can go through the recordings. As well as I'll be if we can share the materials so that you can go through that before having the practical knowledge. So whatever you have learned in these two days, or like what is SQL language? What are the basic commands we ought to follow to create the table? What are the entities? What are entities? And what are tables in the database? What is database? How we are going to store the data? How we are going to retrieve the information from the data? How to create a table using the create table command? What are the columns has to be mentioned? Column followed by the data type followed by the rules, constraints. So this is the basic structure of creating the table. And what are the things we ought to follow when retrieving the data from the table? Simple select star from the table by giving two. If you want to only select only few columns, that one also we can select, and you can use the var class to filter the condition. And in the var class, you can use one condition. More than one condition means you have to use the logical operator. You can use the like operator. You can use the is null and in operator. So what are the operators we can use in the filtering the conditions? How to use the built-in functions of the SQL for single rows and multiple rows? What are the different types of constraints? How they are going to work when you are going to use that in the data definition language? So these are the things you have understood in these 2 days. So these are the introduction I have to give so that when you are going to see the commands practically, you will be in a better knowledge to understand like, okay, this is the way we taught like how we are going to write the queries to create this table in the database. So mostly we'll be using the DB SQLite browser database, which can be locally downloaded and installed in the system. In that we can execute the queries. I will give you the options, show you the options on Monday. So please go through the recordings and be thorough that you are good with this, whatever the concepts covered for these 2 days. And later, once I cover the first chapter queries, followed by I'll be providing you the interview questions for those chapters as well, so that you will be in a better position to understand like what kind of questions can be asked from this chapter, from the next chapter, like that. The sequence you will understand, and you will have some basic idea like what are the kinds of questions will be asked from each chapters. Everything will be provided when we start from writing the queries from the Monday. So any doubts in these two-day session? Are you people clear?
No, why we have to do for foreign keys and primary keys? Why we have to do? Because of relationship only?
Group by, yeah.
No. Foreign keys, primary keys.
Foreign keys
Different.
or foreign keys we have to use for relational. For example, if I want to connect one particular table with another table, I want to use the primary key of the another table. That time we have to go for the foreign key creation. Or else, for example, you will create multiple tables. For example, you create 5 tables. In each table, you can have one primary key. But if I want to connect the first table to the third table, then only you have to go for the foreign key. If you are dependent on the primary key of the another table, that time only. For example, in the student table, teacher table, there are 2 tables out there. In the student table, you have the student ID as a primary key. So this student, you will be referring that in the teacher table so that this teacher having all these students. So no need to insert the records for the student ID in the foreign next teacher table. You will be taking the data for the student ID from the student table itself. It will be auto-populated from the previous table. You no need to insert the records for that foreign key in the secondary table. That is the main thing we are going for, the referential integrity foreign key. Your question is answered?
Okay, but little bit confusing.
Yeah. No,
Practically,
I understand your question. It is theoretically, you cannot, when you see it practically, that time only you will understand. Monday, I'll be writing the query before you. You will understand how the table is creating, how the foreign key is getting populated. I will show you practically. You will be having a better idea. Just get a theoretical knowledge, like we are creating the foreign key in the next table when you are going to depend on another table primary key. That is the concept you should have in your mind. When you see that practically in the query, you will be very clear seeing it practically. And after finishing every chapter, I'll be giving you the assignments, like you have to complete and send it to me, so that you will be practicing along with me. Or else day by day, the concepts will go tougher and it will be, you will find it difficult in the practice. See, whatever you are learning, you should always try to spend half an hour per day in practicing those queries, so that you will get the hands-on. Clear?
yes, yes.
Madam,
Sure.
up to how many sessions are completed, madam?
So far, we have completed yesterday and today's session. This is about the theoretical part. For SQL alone, it will take 20 hours. After that, some at least 15 to 18 hours the SQL will take, and after that only we will be going to Snowflake. 15 hours I'll write all the queries, and 2 classes I will ask you to practice before me. Then I will go for the Snowflake. Clear? Hope today's session was interesting, and I hope all of your queries were answered, right?